Hey students, we're going to start linear programming today, and these are the words and terms that I need you to know. Constraints, you're going to hear me talk about that. Objective functions, super important. Again, using these in context will help, reading them to you won't. But this is all about linear programming, which is just one strategy when you're trying to optimize or find a maximum or maybe even a minimum for. So let's get started. I'm going to use this example to start. And the first thing I'm going to do is you have to read through it and then define your variables, then find either the profit / max min equation, they call that the objective equation, and then create the constraints. And I like to do it in this area, in this order. Begin by, please, reading this problem. And hopefully you have read it, and here's what I'm going to do. I know there's going to be an X, and there's going to be a Y. And my X in this case is going to be the number of spruce trees. And the Y, Trez, is the number of maples. Now, the next thing I do, once I've defined my variables, I go straight for the objective equation. I go to the question that's asked and find out, what are they trying to optimize? What are they trying to find the most of? Because if I can pull those variables and numbers and values out of the equation, it simplifies it for me because they don't double dip on it. They don't use it twice. So here it's saying how many of each tree should the city plant to maximize the carbon dioxide absorption. So I need to find out what the carbon dioxide deal is. And sure enough, I go right here. Spruce trees absorb 650 pounds per year of carbon dioxide. So that means for every spruce tree, it gets 650 pounds of this carbon dioxide, whereas the maple trees, which is my Y, absorb 300. So, I just put Y, and I meant plus 300Y. Now, I don't know what they equal. I just need to find the maximum, but I have now made my objective equation. So I don't need to worry about those numbers or phrases about carbon dioxide at all. So now I'm going to put the rest here under the appropriate column. So they're talking about the city has $2,100 to spend. Okay, so they're going to spend $2,100 bucks. Spruce trees cost 30. Oh, this is going to help. So they cost 30, and the maples cost 40, probably because they're prettier. And then the spruce trees take 600 square feet. So I put 600 here. I'm not going to put the square, just feet. And then maples, 900 feet. And they get how much feet? Oh, the land available is 45,000. So I just had to add the variables. So obviously, now these become my constraints. So obviously, if I take $30 for every spruce tree plus $40 for every maple tree, it had better not exceed the amount of $2,100. Likewise, the spruce trees take 600 square feet of, land area, 600x, plus 900y for the maples, and that had better stay within the 45,000 square feet they've appropriated for that. Okay, objective, here's my constraints, but I did add one that you have to plant at least 30 maples. So the maples is y, so y has to be greater than or equal to 30. All right, now it is time to graph this inequality. Find my corners and plug it into that. Let me write that down. Okay, so I've written the directions here for you so that you can follow them. And I've written my equations before right over here where you can't really see them at the same time. Let me make it smaller. There we go. All right, so before I start to graph, what I like to do is use my X and Y intercepts to find the X and Y intercepts so I can figure out how high to number and how well to number this graph. So I'm going to use this first one, and I'm going to find the X and Y intercepts. If I put 0 in for X, then I get, I think it's 52.5. I did this earlier. I hope that's right. 52.5 for the Y. And if I put 0 in for the Y, then I get 70 for the x. So I know that my y needs to go as high as 52, and I know this needs to go to 70, but now let's do this one. If I put 0 in for x, then I get 50 for the y. And if I put 0 in for the y, 900, I get, is it 75 or 72? 75, I think. I'm going to check my math. Okay, so I checked my math and I did my grid, drew my grid, excuse me. So now I'm going to plot these points. Let me change the color of my pen. And when x is 0, the y is 52.5, which is sort of a guesstimate. And then when x is 70, the y is 0. So now I'm going to connect those 2 points. Okay, I've done that, and I believe I shade down. Let me check by putting 0, 0 in. If 0, 0 is a solution, then the entire region is 0 plus 0 is less than 2100, and that's true. Okay, now let's do this one. When x is 0, the y is 50. Let me get another color. Oh, not red, blue. Okay, so when x is 0, the y is 50, which is right there. And then when x is 75, and I'm going to connect those two. And that one graphs down, and man, they're really close right there. So now, let me blow that up. I need y is greater than 30. So that is a horizontal line that I'm going to do in, I guess, green. And I don't think I need the tool. So here's the 30. Wow, that's going to be close. And it's everything above that, right? So now I have found my area of feasibility. Oop, let me find, and this is it. So that's my area of feasibility. So let's look at our directions. So determine the constraints, did that. Graph, did that. Determine the corners around your area of feasibility. So here we go. Right here, this one I already know, right here is 0, 50. And I know this one is easy, it's 0, 30. But what is this one right here? See, the blue line is meeting the green line. So the blue line is actually the second, the 600x. So if you can't tell, you may have to do this. Plus, oh my gosh, my pen. 900y is equal to 45,000. And I know that the y is 30. So when that y is 30, so 3 times 9 is 27, 1, 2, 3 zeros. So let's subtract 27,000 and find out what that would be. 15 minus 7 is 8, right? And 3 minus is 18,000 divided by 600. Oh, so that must be 30. So that point is 30, 30. Now, I need to make it smaller. Now I need that objective, this one, equation, because I'm going to plug all 3 numbers into it. So when I use coordinates, rather, if I use 0 and 50 here, what would I get? If x is 0 and this is 50, that's 5 times 3 is 15, and add 3 zeros, it's 15,000. Then, and this is carbon soaking in, what do you call that? Absorption. And then, if I use 30, and you would think I'd go inside and get my calculator, but I didn't. I got 28,500, and I did the math, praying it's right. Okay, and then there's a point at 0, 30, which would be 0, 9,000. I'm sorry, would be, yeah, 0 plus 9,000 is 9,000. So which way is it going to absorb the most? And it's this one. When there are 30 maples and there are 30 spruces, you're going to get 28,500 pounds per square year absorbed. So let's make how many of each tree? 30, 30. We've answered it. That's what these are like. Now I'd go through another one, but we're already at 9 minutes and I don't think you'd forgive me. So this is where groupthink is going to be big time helpful tomorrow. You guys take care.